In this video, we're going to talk about how to convert quadratics from standard form to vertex form. Before we begin, let's just review that there are three main forms of quadratic functions. There's standard form, y equals ax squared plus bx plus c. One advantage of this form is that we always know the y-intercept. The y-intercept will always be at 0c. There's vertex form, y equals a, and then x minus h quantity squared plus k. The vertex here is always at hk, and then finally there's factored form, a times the quantity x minus r times the quantity x minus s. And one advantage here is that our x-intercepts are at r0 and s0. In each case, the value of a reveals the direction of opening. If a is positive, then the parabola opens up. If a is negative, then the parabola opens down. And a is always that lead coefficient. Now, there are at least three methods of converting from standard form to vertex form, and that'll be the main focus of this video. There's completing the square, there's partial factoring, and there's something called the shortcut method. Let's talk first about completing the square. When we begin with the expression y equals ax squared plus bx plus c, to complete the square, first we factor a from the first two terms, and then we divide the new coefficient of x by 2. We then square the value that we just obtained, and then add and subtract it inside the bracket that remains after we factor out a from the first two terms in step 1. We'll then have usually 4 terms in the bracket, and what we then do is we distribute out the fourth term, the one being subtracted, and the trinomial that's likely remaining is a perfect square, and we can then simplify the 2 terms remaining on the outside of the bracket, and we have a quadratic in vertex form. So let's show this. Y equals 2x squared minus 12x plus 17. We want to convert this to vertex form by completing the square. Well, like we said, the first thing we can do is factor that lead coefficient from the first two terms. Factoring 2 from 2x squared minus 12x gives us x squared minus 6x. And what we're then going to do is we're going to divide this remaining coefficient, the negative 6, the coefficient of x, we're going to divide it by 2, but we're going to make a point of remembering that. Okay, so the answer is negative 3. We're then going to square that value, we get 9, and what we then do is we refer back to what we had in step 1, and inside that bracket that says x squared minus 6x, we're going to now say x squared minus 6x plus 9 minus 9. Okay, we add and subtract this value that we got. What we can then do next is distribute the 2 only to the negative 9. What that does is it kicks it out of the bracket, turns it into negative 18. And we can now simplify. What's left inside the bracket is, in fact, a perfect square. X squared minus 6x plus 9 is a perfect square binomial, and what we have remaining on the outside, we just evaluate, negative 18 plus 17. Well, negative 18 plus 17 is negative 1. And then x squared minus 6x plus 9, it turns out is actually x minus 3, the binomial, quantity squared. And that's why we said remember this number that you got in step 2, that minus 3. It returns in the final answer. The lead coefficient, that 2, also remains in our final answer. And so we can say that the quadratic 2x squared minus 12x plus 17 is equal to 2 quantity x minus 3 squared minus 1. Now, if we want to graph that, what we can then do is simply find the vertex. So x minus 3 quantity squared means the x value of the vertex is positive 3, and that negative 1 on the outside means that's the y value of the vertex. So we find that point on our graph. That point is at that vertex. Now, something that sometimes people miss is that that 2 actually provides a lot of information. From the vertex, if you go 1 point to the left and 1 unit to the right from that vertex, the number in front, that lead coefficient, tells you how many to go up or down. So in this case, we go 1 unit to the left, we're going to go up 2 because it's positive 2. And if we go 1 unit to the right, we're going to go up 2 because it's positive 2. And so that gives us the vertex as well as these other 2 points and allows us to draw a pretty decent graph of a parabola. Now, we wanted to also know our domain. Well, the domain of a quadratic function will be x element of the reals. And in this case, the range will be y element of the reals such that y is greater than or equal to -1. An interesting note about graphing quadratic functions, it's written out here nicely for you. Once you go to the vertex, you can move 1 square to the left and 1 square to the right. The value of a tells you how many squares to go up or down. Up if positive, down and negative. Down if negative. So in this case, a equals 2. After we go to the vertex, move 1 square to the left and then go up 2, and it gets us here. Go 1 square to the right and go up 2, and that gets us here. It allows us to draw a pretty good parabola. Now let's talk about partial factoring. With partial factoring, if we're given the original function y equals ax squared plus bx plus c, what we want to do is factor ax from the first 2 terms. So what that leaves us with is ax times x plus b over a, and then plus c. Okay? And what that does, after we factor ax from the first 2 terms and we get to step 2, we set ax equal to 0 and we solve for x1. So x1 will be 0, setting ax equal to 0. And then we set the second partial factor, x plus b over a, we set it equal to 0 and solve for x2. And those 2 values are going to represent values of x that produce a y value of c. Now, why is that important? What it means is that when x is 0 or when x is negative b over a, we will have the same y value. Since parabolas are symmetrical, that means halfway in between those 2 y values, those 2 x values, will be the x value of the vertex. So in other words, in between those 2 x values, which would give the way to evaluate a number halfway in between 2 given numbers is to say x1 plus x2 quantity over 2. In between those 2, we will find the x value of the vertex. So the axis of symmetry will be at the vertical line x equals x1 plus x2 quantity over 2. We then take that x value that we get and we plug it into the function equation to determine the y value of the vertex. And so we now know the vertex, h comma k. We also know the value of a, which is literally it's the lead coefficient of the expression in standard form. And so we now know the equation in vertex form, y equals a bracket s minus h quantity squared plus k. All right, let's see this done with an example. We're given y equals negative 3x squared minus 6x minus 1. First thing we do is we factor ax from the first 2 terms. So in this case, a is negative 3, so we factor ax from the first 2 terms. Factoring negative 3x from the first 2 terms gives us negative 3x times x plus 2. We set each of these 2 partial factors equal to 0. If we set negative 3x equal to 0, then x is 0. If we set x plus 2 equal to 0, then x is negative 2. Next, we try to find the axis of symmetry, so we just add these 2 x values and divide by 2. When we take negative 2 and add 0 and then divide the result by 2, we get negative 1. What that tells us is that our vertex has an x value of negative 1. To get the y value, we simply go back either to the original expression for y or another expression for y that we obtained along the way. we plug in that x value. So in this case, we plug in an x value of -1. When we do that, we get a y value of 2. And that lets us know that the vertex is at -1, 2. Well, we know from our original view of the equation of the parabola that our value of a is -3. And so therefore, y equals -3, quantity x plus 1 squared minus 2. Okay, now to graph that is pretty straightforward. We change the sign here, so instead of x plus 1, we'll say we have a vertex with an x value of -1, and then this part at the end remains the same, so the y value of our vertex will be -2. So we go to -1, -2, and we have the location of our vertex. And again, this lead coefficient of -3 is actually rather informative. We go 1 square to the left and 1 square to the right from the vertex, and we go down 3. And when we do that, we've got a couple more points on the parabola, and we're actually able to draw a pretty good parabola. And then we're able to say what the domain and range are. The domain of that quadratic function is x element of the reals because it's infinitely wide in both directions. And the range is y element of the reals such that y is less than or equal to -2. And then finally we get to the shortcut method. X equals -b over 2a. The x value of the vertex will always be x equals -b over 2a. You can look at that by looking at the quadratic formula. We know that the zeros from the quadratic formula are x equals -b plus the square root of b squared minus 4acl over 2a, and -b minus the square root of b squared minus 4acl over 2a. If we add those two zeros together and divide by 2, you will get x equals -b over 2a, and that's the equation of the axis of symmetry, and that's the x value of the vertex every time. Another way of looking at it is simply to say this: y equals ax squared plus bx plus c. If we do partial factoring, we know we get this. So that tells us that plus c. Using the method of partial factoring, we see x could equal 0 or x could equal -b over a. We then add these two zeros and divide by 2, and that gives us -b over 2a. However it is we like to think of it, the x value of the vertex will be -b over 2a. We're then going to take this x value of the vertex, -b over 2a, and we're going to sub it into the original function equation, and that's going to help us determine the y value of the vertex. And then we'll know the x value of the vertex and the y value of the vertex, so we'll know h and k. We'll also know a from the equation of the parabola that we're given, and then we'll be able to write our function in vertex form, y equals a bracket x minus h squared plus k. So we'll use this method for this question here. 4x squared plus 16x plus 11. Well, we see that the x value of the vertex will be at -b over 2a, which is -16 over the quantity 2 times 4, which is another way of saying the x value of the vertex is -2. If we let x equal -2, then we'll see that y ends up equaling -5. So we'll have a vertex hk of -2, -5, and we'll have a lead coefficient of 4. So if a is 4 and h is -2 and k is -5, we'll be able to say that y is equal to 4 bracket x plus 2 quantity squared minus 5. And we can graph that pretty well. We know our vertex will be at -2, -5, which is down here. Because that lead coefficient is 4, that just means if we go 1 square to the left and 1 square to the right, we go up 4 units. And gives us a couple more points on the parabola. We can draw a very effective one. Our domain will be all real numbers, and our range will be all real numbers such that y is greater than or equal to -5.